we on? Okay, Brian, sorry, so sorry you're not with us. So we have a Brian substitute. Kevin joined us and taking your place and is also recording this for you. So, all right, so let's look at where we were on day 2 notes. Can you shine, put this in front of the camera, show him MD where we are.
We are
here at the last page.
This page.
And we were talking about sampling from a bag or a
There,
truckload.
maybe? Yeah, there.
And we found out what about the sample, if the sampling scoop is scooped out of the bag or if it's scooped out of a truckload, what is the difference? What's the construct about that? Okay? Doesn't matter the population size.
No.
It doesn't. So surprise, surprise. All right, we have a check your understanding there. So let us proceed with that. The histogram above left shows the intervals in minutes. Oh, our old friend. Remember we used to talk about this every day. We're back to talking about Old Faithful and the time in between eruptions. So you can see that there's a what's it called when you have 2 peaks? Bimodal. It's a bimodal distribution. And could you show him that again? The bimodal. Show him which one to show him. All right. So 2 peaks because if it doesn't erupt at 1 minute, it'll probably erupt at another minute. So they're around 50 and then up to somewhere around 80. So that's the general tendency of this geyser. So they took the 500 values of a sample median are displayed in the histogram, and the median is 75 for the one for that. So the median is 75. So number 1, is the sample median an unbiased estimator of the population mean? So looking at the first graph, the one on the left, the small one, is it biased or unbiased? What do we look for when we're looking at a graph to tell if the statistic is biased? MD, what do we always look for?
You look for the center.
Right. So, and we're hoping the center will be at 75. So, is it? What do you think, MD?
Yes. It's kind of hard to tell on this graph, but I guess you
is.
could say it's like ish. So, like, no, I don't know. I want to add it. Yeah, because it has like 4 things, and then the other side has 7, and they're yeah. But I feel like it could add up to that.
I think I'm gonna have to cheat on that because I don't know where the mean is.
I think it does.
Doesn't it say the mean of the 500 sample median value 73.5?
Yeah, it says the mean.
Oh, it tells you. That's good. All right, where is it? I knew I was something wrong here.
The last sentence.
What's the mean, MK?
73.5.
All right. So, and we were hoping to get the mean of the sample. It tells us. So, whenever they give you a graph that you can't tell with your eye, you're going to have to be told. So, I was looking at that. So I don't know what to do with this graph, but it told us the mean is 73.5. So is that equal to 75?
No.
It is not.
Does it have to be exactly equal?
So
So it's biased.
when I was doing this, before I looked at the answer, I said it was unbiased. I thought that was pretty close.
Yeah, it is.
But, of course, they said it was biased. So it's interesting. So let's go on and see how they developed that. Suppose we had taken a sample of size 20 instead of each sample was 10 observations. Now we're going to change it to each sample being 20. So we're going to grab 20. So what's that going to do to the spread?
It's gonna make it smaller.
It does. Larger samples make smaller spread, and we beat that up yesterday. So so we still got it. We don't have to beat it up again. Describe the shape of the sampling distribution, and the sampling distribution for median is the second one when they took they changed the sample size. So, what is the shape of that one? So I'm talking about the one that's not as dark, the lighter one. So MK, what's the shape of that?
Unimodal.
Right, and what else?
And,
You say it's symmetrical or skewed?
I don't know. I get it could be
Skewed.
skewed.
All right, it is skewed. And do you see that little bit over here,
Yeah.
like that? So it is skewed, and therefore, the question that remains, and I'd like to have everyone's answer on this, what you think. Explain what this means in terms of overestimating or underestimating the population median. So we're going to look at the mean of this. Do you remember what happens to the mean when it's in a skewed distribution?
Oh no.
It moves.
The mean
It
goes.
moves. Remember, the median pretty much stays the same because it's the middle number. So it doesn't matter if you add a really high number like 1 billion, it doesn't really change the median very much. So the median stays the same, but it's the mean that is, remember, it's not resistant to extreme measures. So it's going to move from there somewhere in here. I don't know where the balance, does that look like it's balanced? Not to me. All right,
I
let's
still don't
go
understand the
like
whole
that. We'll
balance
make
thing.
it long. Now it might look like it's balanced. All right, that's my mean. So if it's balanced there, so how many dots are overestimated? So these are all made of samples, and each sample produced a median. So we have all these dots on this area, then we have all these dots on this area. So, which are we, and more of those, which one has more, do you think, on a skewed distribution? Are more of the dots overestimating? Are there more dots overestimating or more underestimating? What do you think, MK?
I think overestimated.
And what about you, MD?
Go with MK's.
Do you think
Overestimate.
there's more under this curve than there are under this
It
one?
depends. It's like when you have different glasses of water. One's tall and skinny, and one's
Yeah,
fat.
I know. I know. Well,
That's
we're
a good
just
analogy,
to
Em.
look at that and answer that question. So, you have to weigh in. What do you think, MM?
I'll be the contradictor.
Yeah, okay. Do you think there's more dots on this one?
Sure, we'll just.
All right, so the answer is, the sampling distribution is skewed to the left. This means that in general, underestimates of the population median will be greater than overestimates.
What does that even mean?
Would you open your book to page 427? 427. And can you see, this is the tank problem. I'm not going over the tank problems again, but which one of those tank ones is skewed left? Do you see what I'm talking about on page 427?
The last one.
All right, the bottom one called what, partition? Do you see that
Yeah.
skewed left? All right, look at question B. Read question B, MK.
Why is the partition method, which uses the statistic 5/4 times the maximum, recommended by mathematicians in Washington?
Okay, so that, I don't want to go through that, why they picked that, but would you read B to me, MD? Read the answer B.
The partition method uses the statistic 5/4 maximum. That is an unbiased estimator, and that has much less variability than any of the students' team's statistics. Its sampling distribution is left skewed, which means that the statistic is more likely to overestimate than underestimate the number of
All right,
tanks.
wait a minute. Read that sentence again.
It's left skewed, which means it's more likely to overestimate than to
Now,
underestimate.
is that the opposite of what we just read?
Wait. Assuming it's
More
less
likely
skewed, it's more likely to over.
That's
Yeah,
saying
it.
there's
think our
more
dots stopped
dots
blinking.
under this,
Yeah.
and yet on